Next thing we want to look at is multiplication. And so many times we think multiplication makes bigger is a term we use. So I want you to kind of keep in mind that that's not always the case. That's a common misconception, because when we first do whole numbers, multiplication makes bigger. But then once we start thinking about decimal numbers and fraction, multiplication doesn't always make bigger. But let's look at the algorithm first. So 437.09 times 3.8. Well, again, knowing that these are fractions, what you do is you turn these into fractions, and then you just multiply, right? Top times top, bottom times bottom. And then notice here, right, your denominator is a power of 10, and then you can move them back. So you can see that once we do that, as we multiply, right, it's the same as multiplying these without, right? Multiplying these without a decimal, and then you count how many, and then you move the decimal point back, right? The other thing is that what we do is you just multiply and you count. There's 3 decimal places. Well, there's 3 decimal places in this answer because there was 2 decimals, hundreds here, and then a power of 10, 1 decimal. And so when you multiply that, you get 3 decimals. And so that's why you'd simply just why we move the decimal point when we multiply. Again, it's based off of the denominator of the original fraction, right? And so when we're multiplying the denominators, the base 10 denominators, that is then what's going to determine why we move the decimal point, right? And so looking at that algorithm, you'll see that what most students do on an algorithm as a fraction, what you would do is you would then say 437.09 multiplied by 3.8, and you just multiply like there was no decimal, right? 72, sorry, it's a 2, put a 7, there's your 7, 8 times 7 is 56, 8 times 3 is 24, plus 5 is 9, put the 2, 8 times 32 plus 2 is 34, right? Am I doing this right? Yeah, damn, let's see. Then you put a 0, 3 times 9 is 7, add the 2, 3 times 0 is 0, plus 2 is 2, 3 times 7 is 21, 1, 2, 3 times 3 is 9, plus 2 is 11, 4 times 3 is 12, plus 1 is 13, and so you end up with that there. You end up with a 2, 4, carry the 1, 9, and so you end up with that number, and then you move the decimals, 3 decimals, you move it over, and so then you end up with that right there, which we have here. But again, that comes from our fraction. So you just multiply the numbers like if they were no decimals, and then you move the decimal place, the number of decimal places, because that is the place value for the denominator. And so that, again, put that in your own words. When you get that, you may need to read the book or listen to what I explained again. Here's an example of just making multiplication makes bigger does not hold, right? This number is 12.2, 12.5. So it doesn't always mean you're going to get a bigger number. This also carries over to division in terms of many times with whole numbers, division makes smaller, but doesn't necessarily the case also in division of decimals or fractions. But let's look at the algorithm here. 154 plus 0.63 divided by 4.7. Again, the technique is let's make these into fractions. And now that we know what to do with the fraction, how do we solve that? Right, what happens is that then this problem here becomes 15463 over 100 multiplied by 100 over 470. So those cancel. So it really just becomes the problem 15,463 divided by 470. With no decimal places. So that becomes the equivalent division, and you end up with 32.9 right after dividing that, however you would divide that. That's why when we get this algorithm, what are children told to do? What they're really told to do is kind of fool around with, they say move the decimal, move the decimal. And so when you do that, what we're really doing is when you have 154.63 over 4.7, if you move the decimal, right, move the decimal, what you're really doing is multiplying the top and bottom by 10, right? So if you go 154.63 times 10, all over 4.7 times 10. Your answer is move the decimal. You're going to end up with 1546.3 all over 47, which becomes that problem there. And that's why we move the decimal when dividing. You're really just multiplying by 10 or 100, right? The other thing is we could have moved this over 2 decimal places, 1, 2, multiply this by 100, which means then multiply this by 100, and then you get this here, which is came back to what we ended up over here, right? That same division. So there's so many different ways to think about division. You want to practice that, but really think about, again, why the algorithm is just to move those decimal places. Something to think about with that.